Hello everyone, can you solve this advanced looking expression without even finding x? So let's see how powerful algebraic identities really are. So we are given x plus 1 by x 3 and we are asked to find x power 5 plus 1 by x power 5 without solving for x. So let's use the identities to climb up from what to know or what do we need. So our first step is to find x squared plus 1 by x squared. So I'm going to use x plus 1 by x whole square minus 2 we can write. So the value of x plus 1 by x is 3. So 3 square minus 2 which is equals to 9 minus 2 that is 7. So x square plus 1 by x square is 7. Now, our next step is to find x cubed plus 1 by x cubed. Its identity is x plus 1 by x whole cube minus 3 times x plus 1 by x. So, x plus 1 by x is 3. So, 3 cube minus 3 times 3. 3 cube is 27 minus 9. So, x cube plus 1 by x cube is 18. Now we have to find x power 5 plus 1 by x power 5. So we will combine both the formulas. So x power 5 plus 1 by x power 5 is x square plus 1 by x square times x cube plus 1 by x cube minus x plus 1 by x. So the value of x square plus 1 by x square is 7. Times, this is 18 minus, and this as per question 3. So 7 times 18 is 126 minus 3 is 123. So did you notice that how we never actually solved it for x? So that's the magic of algebraic identities. Olympiad math, they let you want indirectly but accurately. So you can use this technique wherever you are asked to find symmetric expression like x power n plus 1 by x power n. So the answer is 123. Did you get it before I did? So let me know in the comments below. And if you love building power from one line to next, hit that like and subscribe. And this is just one, and we have a lot of questions coming soon. So see you in the next video.